Hi y'all, today we are solving by graphing. So we're solving quadratic equations, and to solve a quadratic equation means to find the x value or values that makes the equation true. So in order to do this, we're going to look for the x-intercepts. Right, so x-intercepts, super duper important piece of the graph. I have three possibilities here. So the first possibility is that your graph looks something like this, right? And you can see that it is crossing the x-axis here. It's crossing right here, and then it's going down, coming back up, and crossing again right here, right? So this is what we would call two real solutions, because there are two solutions to that graph, two places where it crosses the x-axis. So then you can imagine that if your graph looks like this and comes up and touches it and then goes back down like that, it only touches in one place, then that would be considered one real solution. It could also look like this, right, and be facing up that way, but both of those would be one real solution. And then the last possibility is that there is no solutions, right? There is no place that it crosses the x-axis. So we would say that this has no real solutions. I'm gonna put the word real in there. No real solutions. That's because at no point does it cross the x-axis. So when we're thinking about solutions here, or solving, we are only looking for the x-axis and the number of places that it touches there. So solving by graphing can be really good, and because it can help us to see. So I'm drawing this line here. I can see, okay, there is a solution at x equals -3. And then I'm going to keep going, goes down, there's my y-intercept, touches the x-axis again here at 1, right? And then continues to go up it forever and ever, right? So I would say that this has two solutions, right? And the two solutions are x equals -3 and x equals 1. All right, so that's when this is really good. It's really helpful when we can see the lines. So when we can see the exact point, that's really great. What's not so awesome is when we can see that it's in the middle of two numbers. So if we're looking this way, right, there's this number, but I don't really know what that is, right? So like somewhere between 0 and 1. So somewhere between 0 and 1, I don't know about that. And then I'm going down this way, going back up, right there. Maybe it's like close to 3, but less than 4, right? So I don't really know that one either. So it's solving by graphing is not that helpful if you just have the points like that. And so it's not so good. So there's some situations in which it's good and some that where it's bad. So in situations where it's bad, right, if we're thinking about this type of equation here, right, situations where it's bad is when it touches at like some strange point here. We can use our calculators in order to help us solve it. So I have Desmos here on my phone. I'm going to go ahead and graph this equation here. I'm going to graph 2x squared minus 8x plus 4. So that's my graph there. And then I want to find the exact solution. So I'm just going to tap on the solution. So I'd say, oh, okay. So one of the solutions is x equals 0.586. That's this one that's somewhere between 0 and 1. Right, so 0.586. And then I have my other one here. Oh, okay, the other x is x equals 3.414. But I'm only able to do this on the calculator, right? So I want to make sure that I know how to do that. I've also included the directions here for how to do it on the yellow calculator. So that should be helpful as well, but we'll go through that in class. And then finally, I have some ACT practice here. So I want to make sure that we are getting ready to see what this would look like on the ACT. So we can see that we have a parabola here, and it says in the xy plane above, the parabola with vertex v, so we know this is the vertex here, is the graph of a quadratic function. We can see that in the parabola. Right, so this is quadratic. Which of the following must be coordinates of another point on the parabola? So I need to look and see if any of these points, right, could be on my line here, right? So since they really only give me they only give me 2 points of information. They give me the vertex and P. The only thing I really know is that there should be another point right over here, right over there. And the way that I can figure that out is by using symmetry. So I can see, okay, so if this is at -3, -2, so -2, -1, 0, 1, 2, 3. So I'm going from -3 all the way to +3. That would be going up 6, right? So I can go up 6, the same amount of 6 over here. That'd be going up 6. And then I can see that I'm going from, if I'm going like out this way, I'm going from -2 to -5. Right? From -2 to -5 is 3 spaces. So that would mean that I need to go 3 more spaces. -1, -1, 0, whoa, -1, 0, and 1. That would be how I get to this space right here. So I know that that was over 1, right? And then this point here is 1, 3. 1, 3 would be my answer. Alternatively, another way you could think about this is, let's say you know that you have this point here. You could say, okay, I'm going to go up 1, 2, 3, 4, 5, 6. Right, so I know that the point's going to be on the same number, right? So I know it's going to be at 3. And then I could cross out this one. That's not a 3. This is not a 3. That's not a 3. And then I could decide between C and E. So then I'd say, okay, this is 1, 2, 3 to get out here. So I'd have to go 1, 2, 3 to out there. So if that would be at 1. Right, so I can see that C would be my final answer. Right, so we're really just using symmetry in this problem. That's pretty much it. Today you're just going to be working with your calculator a lot. Ask me for help. Thanks, guys. There's also a video for this section here. There's another video that I liked on Canvas. So check it out. Thanks.